Good morning. We're going to burn through this. How's that sound? Okay. All right. So here we go. We are looking at segment lengths now. Up until this point, everything we've been doing have been arc and angle inside the circle. Okay, so the measure of the arc and the little angle, but today we're actually looking at the lengths of segments within circles. And there's some special relationships that we come across here. So again, there are three different types based on whether or not we are in that intersection is inside the circle. We have one relationship. But type 2 and 3 actually are pretty much the same relationship, which I'll talk about in just a second. So whether we have secants that are intersecting outside the circle or we have a tangent and secant, again, that's outside the circle. They pretty much follow the same pattern. So here, when we have two chords that are intersecting and that intersection is inside the circle, it turns out that we have these little segment lengths here, so maybe it's 5 and 7, okay? It turns out that all we have to do is the product of the pieces are equal. So A times B is equal to C times D, all right? The product of the pieces are equal. That's all it is, all right? That's our equation for setup. Not too shabby? All right. So the other type 2 and type 3 actually turn out to be pretty much the same. And the way I think about it is there is, when we look at type 2 here, there is an exterior section. This little bit, that exterior that's outside the circle. And then I can consider the whole entire secant line. And that is it. For these two types, the same thing occurs, the same type of relationship. It's just exterior times the whole thing. Exterior times whole. So when I look at this picture here, what's the exterior portion? Just the A and C. So I'm going to start with the A. All right. And then if A is like 5 and B is like 7, what's the length of the whole thing? 12. How'd you get 12? 5 plus 7. You're just adding. So we want exterior times the whole thing, the A plus the B, added together. So exterior times whole is going to be equal to the other exterior times whole. So what's the other exterior portion? On the other secant line? C, and then what's the whole thing? C plus D. All right. Exterior times whole is all I think about when I set up these equations. So the product of the pieces or exterior times whole are the only things we have to think about. The last one is sort of the same, but because we have right here, we have a tangent line. Well, if I'm going to do the same process, what's the exterior portion? The A. And what's the whole portion? Nope. What's the whole thing? A. It's the exterior and it's the whole thing. Is equal to, on the other secant line here, what's the exterior part? B, times, what's the whole thing? B plus C, adding them together. All right, so it's exterior times whole. That's all we have to think about. And, or this one is just a product of the pieces. So with that in mind, let's look at number 1 and 2. So number 1, again, we have this intersection inside the circle. And so what's my setup? How can I set this up? Good. 14 times 15. A product of the pieces is equal to a product of the pieces. So 10 times x. That's it. What is 14 times 15? 210. All right. Equals 10x. And to divide by 10, we get 21. That's pretty easy. All right. Number 2, you can see, is part of the delta math. So this is what you're going to see on delta math on number 2. Given that, on the circle below, we have chords U, V, and WX. So those are chords. You can see the intersection is inside the circle. We want to find the length of XY. What's missing? If that's what I'm trying to find, what should I put in there? An X. Yeah, put in the thing. We got to try and solve for X. So let's put it in there. All right, so we have chords. So what's our setup? Yep, 23 times 22, the product of the pieces, is equal to the product of the pieces. So 17 times x. All right, what is 23 times 22? 506 equals 17x divided by 17. It says round to the nearest tenth. So I get 29.76, which is going to be 29.8. All right, questions on that? Okay, cool. Then let's skip down to number 5. Again, this is another delta math type. Given the circle below with secant lines, JKL and NML. I don't know why they use 3 points for that. It's kind of weird. Find the length of segment JK. So we want to find the length of the segment JK right down here. What should I put on there? An X, because that's what we're trying to figure out, just that length of JK. Now, this intersection of these two secant lines, that intersection is outside the circle. So what's our setup that we're going to do here? What's the generic word?
9 times 9 plus
10. 9 times 9 plus 10, which would be exterior times whole? All right, exterior times whole. So exterior is 9. The whole thing is 9 plus 10. Well, could I just go right to 19? Yeah, you surely could. Okay. And then here, exterior times whole. So the exterior is 10. And what's the whole thing? 10 plus x. That one you do have to leave. All right, so exterior, so this is 9 times 19, which is 171. What do I have to do on the right-hand side? Distribute. So that's going to be 100 plus 10x. And then what should we do? Subtract 100. So 71 equals 10x. Divide by 10, we get 7.1. That's math I can do in my head. All right, questions on that one? Exterior times whole? Easy? Yeah? Okay, good. Let's turn the page. I don't feel the need to do another one of those. Let's look at 9 and 10 and 11 and 12. All right, so once again, here on number 9, this is a tangent line because it's just touching. Remember, tangent means to touch, so it's just touching. And then here we have a secant. A secant passes through. But it still follows the same exterior times whole. So on the tangent line, what's our exterior? 24, and the whole thing is also 24. Exterior times whole. And then on our secant line, what's the exterior portion? And what's the whole thing? 18 plus x. So there's our setup. Exterior times whole. Exterior times the whole thing. 24 times 24 is 576. And then we're going to distribute 18 times 18 is 324 plus 18x. And then what should we do? All right, 576 minus 324 is 252 equals 18x. And then divided by 18. X equals 14. All right, number 10. Again, you can see this is delta math. You like to use words. Given the circle below with secant and tangent line, find the length of yx. So we want to find the length of yx. What should I do to my picture? Mark it with an X. X marks the spot. That's what we're trying to find. Okay, funny. All right, so what should my setup be? Exterior times whole equals? All right, exterior is 13. The whole thing would be 13 plus X. Exterior times whole. Do we need to solve that, or can you do that? You're good? Okay, excellent. Then we also need to do like number maybe 11 and 12, I think. Oh, no, let's do 13 and 15 since those are delta math ones. Man, I didn't realize I did all this work here. That's cool. All right, let's look at number 13. So we have a secant line and a tangent line. We want to find the length of MN. So what should I do with mark it with an X? Yeah, So what is our exterior times whole setup here? X times X is equal to, well, careful. The exterior portion is 24. All right, 24 plus 24. Okay, so the whole thing would be 48. So we get X squared equals, let's see, oh my goodness, 24. So this is 24 times 48, which turns out to be 1152. How do you get X by itself? Square root both sides. Very good. So we get X equals, and then it says the square root of my answer, 33.94. 0.94. It says round to the nearest tenth, so that's going to be 33.9. Good? Yeah. Do I need to do 15? No. All right, cool. You guys have a delta math. It's ready to go.